All right, so after that last one, we got a huge turnaround back the other direction. When that happens in a problem set, you'll notice a lot of times they get tougher and tougher, and they just kind of reset. It usually means that we've jumped between sections or even between chapters inside of a problem set. So you'll check your addendum, look at our calendar, and you'll see that we've moved on to the next little part. So two quick little questions about springs, and then that's it for this one. So the special force from a spring, a lot of times, F for force and S for spring is just how that's represented. This is a formula, comes in a few different variations, and we'll see, unfortunately, it'll look a little bit different when we come back to it. We see it again later. But we have something called Hooke's Law. And Hooke's Law says that the force on a spring comes from a spring constant. Now, it comes from the word constant in German, I believe, and so that's a K instead of a C, but that's just that constant. It's right here in the question. So that's easy to find. Multiplied by the change in length of the spring. So it doesn't matter, as it turns out, if you squish it down or stretch it out, as long as it's the same change in length, you'll end up with actually the same force. The good news is compression, there's your change in length. So here's delta L, and everything here lines up as well as it ever could, right? We see meters on this part and meters on this part, and obviously this K, this constant, has a combination of stuff. That's going to be a running theme, a trend that we're going to see moving forward, is that often your constants have ugly units because they're meant to sort of put things together and cancel stuff, right? So it performs different jobs that make the units complicated and usually just sort of work out for the best. All right, so K is 55.53 newtons per meter. Again, just straight from the question, nothing to figure out there, just plug it in. Then delta L is 0.25 meters. And here's the purpose now of those units. These per meters and these regular meters are going to cancel, and we'll have newtons left over, which, as it turns out, is exactly what we're looking for. So it sets the value for this special type of spring, and then also sets the units to cancel and leave over just what we need. So with that information, now we can come back and get an answer. All we saw left over were just newtons. Taking and multiplying these now, we get 13.88. So you'll notice question 9 was quite a bit easier than even probably the last few.